explain each of the following in terms of kinetic particle theory. So here's a statement, and they want us to explain the statement in terms of kinetic particle theory. A liquid has fixed volume. So we need to explain why a liquid has a fixed volume. Why? But takes up the shape of the container. So it's not like solid, like if you have this container and you have a solid in it, the solid is not going to take the shape of the container. It's going to have its own fixed shape, right? So here's the solid. It does not take the shape of the container, but liquids will flow and take the shape of the container. So two things we need to explain right here. A gas, on the other hand, also takes the shape of the container, as you can see over here, but it does not have a fixed volume. So we need to explain those four things. So let's start with the fact that they both take the shape of the container. And the reason both liquid and gas take the shape of the container, like opposite to solids, for example, and the reason is that the particles are not fixed in their positions. The particles have the ability to move randomly, okay? So that's going to be your first point, and this first point will explain both the fact that they take the shape of the container in liquid and gas, all right? So you're going to say both liquid and gas take the shape of the container because you're going to explain now, okay? Take the shape of the container because particles in liquid and gas move randomly, all right? They have the ability to move, and because they have the ability to move, they flow. And they take the shape of the container, opposite to solid. In solid, particles are not able to flow. Why? Because they are fixed in their positions, tightly packed. All right. So I've explained two things here. Now let's talk about the fact that liquid has a fixed volume, but gas does not have a fixed volume. And the reason here has to do with the forces of attraction in liquid and the forces of attraction in gas. The forces of attraction between particles in liquid is way stronger. So the particles are held together. It does not just escape and go everywhere. In gas, the particles, here are the particles in gas, have weak attractive forces, and therefore the particles are able to just go anywhere. They don't really have to stay with the sister particle, okay? In liquid, they have to stay close together because there's a force of attraction keeping them close together. All right, so how do you explain this in words? You're going to say in liquids, particles have stronger, and I'm saying stronger because it's not strong as solids. They're just stronger than gases. So particles have stronger forces of attraction between particles, okay? Stronger in liquid. I would prefer there are instead of particles have, okay? Because these forces are not inside particles. These forces are between particles. So you're going to say there are stronger forces of attraction between particles. Attraction, okay, between particles, and therefore the particles have a fixed volume. The particles stay close to each other. Particles stay close to each other and therefore fixed volume. All right. But in gas, you're going to explain that there are essentially almost no forces of attraction. Okay. So almost no forces. There are forces, but they're very, very, very weak. Almost no forces of attraction. Or you can say very weak forces of attraction between particles, and therefore no fixed volume. Okay, you can say therefore they're very far apart and therefore no fixed volume. All right, so where are the keywords? The fact that they take the shape of the container because particles move randomly is one mark. The fact that there are stronger forces of attraction between particles in liquid and therefore they are close together and therefore fixed volume is one mark. The fact that there are very, very weak forces of attraction between particles in gas and therefore they're far and therefore there's no fixed volume, that's your third mark.